So we've talked about different spatio-econometric models. I also want to talk about two different models for network statistics. So remember that in network statistics we also have the network, and we have features of the nodes, we have features of the dyads, the ties. But the purpose here is to try to explain something about those ties. In sociology, for example, we might try to use models to investigate who becomes friends with who. In international relations, we might have models to try to explain which countries are more likely to fight wars with which other countries, or to end up in the same trade agreement or environmental treaty with other countries, and so forth. So one of the main models that here is used is the exponential random graph model. And the main trick, the main idea behind this model is that it deals with the problem of high interdependence in observations by taking not the units or the ties as observations, but the network as a whole. So it tries to estimate what is the most likely sort of network configuration. So the dependent variable is the layout of the network. And the independent variables can be features of the nodes and of the ties, but also all kinds of statistics calculated on the network as a whole. How likely are there to be triads? How likely are, if unit A and B are connected and C and B are connected, how likely then are A and C connected? Or if A is connected to B, how likely is B then to also connect to A? And so forth. So there's all kinds of statistics we can calculate on the network as a whole and try to estimate parameters that estimate how important each of those features, these characteristics, are in explaining the network that we observe. So some of those statistics are just statistics about the nodes. Yeah, so we can look at the importance of a particular x variable in how likely it makes that x variable, that node, to create ties. Or we can look at how important it is that two nodes are similar to each other for them to create ties, or dissimilar to each other for them to create ties. Yeah, or we can have particular features of some tie that then influence other ties, like do countries that trade with each other, are they less or more likely to fight wars with each other, and so forth. So all of these we can incorporate as summary statistics for the whole network into an ERGM model. So the ERGM model tries to estimate under what parameters, so each of these summary statistics has an associated parameter, under what parameters is the network that we observe the most likely relative to all other possible networks that we could have observed for the same set of nodes. And so that way we then try to estimate the importance of each of these summary statistics. So the key here is really this idea of looking at the network as a whole. A network that looks like the network that we have, that has the same amount of transitivity, reciprocity, similar states, nations being connected to similar nations or different to different nations, and so forth. To what extent is that kind of network now more likely or less likely than any other type of network? We estimate the betas that make the network that we observe the most likely. Now, we can't really estimate how likely all other networks are because there are too many of them, and it would be an incredibly complicated calculation to evaluate one network against every other possible network. So what we do is we look at the log odds, we look at the ratio of two networks, and we look at how if one tiny feature changes, one tie is created or removed, how much that changes the likelihood of this particular model. So we can look at the odds. If we take the current model and we change one tie, we either remove one tie or we add one tie, how much more or less likely does it make that network relative to the one we have? And then we can explore all the different changes one by one. So we're basically looking at a sort of a logistic regression where at the local view we are comparing the binary variable of having a tie. So is there a tie or is there no tie? And we can compare these two networks. So this ERGM model really only works with these binary kind of ties. You either have a tie or you don't. So it's not so much about valued networks where, for example, trade flows are estimated. But it can be used very well to see whether two countries fight with each other or not, are members of the same organization or not, and so forth. And each time we can locally look at it looks like a logistic regression where the dependent variable is having a tie or not. And then we can look at the log likelihood of the ratio of the log odds between a network that does have this tie and that doesn't have this tie. And then taking into account all the summary statistics that we have incorporated in the model.